Find and simplify the difference quotient for the quadratic function f of x equals x squared minus 5x. So the difference quotient is just our average rate of change from chapter 1 for two more generic points. So instead of having specific numbers that we're looking at for our average rate of change interval, we're looking at our function from x to x plus h. So we're just using these two generic points. So our formula for that after we plug into our average rate of change is always going to look like f of x plus h minus f of x all over h. So as a first step, I'm going to find my expression for f of x plus h. So this is telling us to evaluate our function by plugging in an input of x plus h. So in the original function, everywhere I see an x, I'm going to replace it with an x plus h. So it gives me x plus h squared minus 5 times x plus h. So the original function had two terms. Each of those terms have the x replaced with x plus h. Now we can go through and clean this up a little bit. So x plus h squared, I'm going to go ahead and write that twice to help me think through how to FOIL that. So we have x times x is x squared plus xh plus xh plus h squared. So that's from FOILing x plus h times x plus h. And then distribute minus 5x and minus 5h. Those two xh terms are like terms, so we can go ahead and combine those together. Write this as x squared plus 2xh plus h squared minus 5x minus 5h. None of the others here are like terms, so we can't simplify that any further. So now let's think about taking that difference quotient formula and actually plugging in, so finding this average rate of change. So I'm going to take my f of x plus h that I just found, and I'm going to subtract my original function f of x. So for f of x, we're going to be using that original function x squared minus 5x, and then I'm going to divide all of that by h. So f of x plus h, that's what we just found. So I'm going to start by taking x squared plus 2xh plus h squared minus 5x minus 5h. And then I'm going to subtract my original function. So my original function is x squared minus 5x. All of that's going to get divided by h. So there's a lot of terms up in the numerator, but we have some like terms. Notice if you take x squared minus x squared, those cancel out. If you take a negative 5x minus a negative 5x, those cancel out as well. So let's write down what's left here. So we're left with 2xh plus h squared minus 5h all over h. Notice that each term in the numerator has an h in it. That should happen every single time when you're doing these difference quotients. If you get to this step and you have a term in your numerator that does not have an h, then an error has happened on the previous step and we need to back up. So either we don't have the correct expression for f of x plus h, or we made an error as we were canceling like terms. So because each of those terms has an h, we're going to be able to simplify. So that h in the denominator is dividing each of those terms from the numerator. So you can think of that as three separate divisions that we want to do. So when you have a 2xh and you divide by h, the h's cancel and leave just 2x. When you have an h squared divided by h, one of the h's from on top cancels with that h on the bottom, so it leaves just an h. And the h on top with the h on the bottom leaves a minus 5. So our difference quotient is going to be the expression 2x plus h minus 5. If we were to pick some numbers for x and h, so we were looking at actual points, then we would have a number for our difference quotient since it's an average rate of change as well. Because we're using these generic points, x to x plus h, then our final answer, our difference quotient, is still going to have those variables in it as well. So start by finding an expression for f of x plus h, so evaluating your function for an input of x plus h. Use that output from your evaluating for f of x plus h to then plug into your difference quotient formula, subtracting the original function and dividing by h, and then being careful as you simplify from there.